Hi girls, welcome back. Let's have a look at the second part of nitriles, that is looking at how something like hydrogen cyanide attaches across a carbonyl. So we're going to be looking at the production of hydroxynitriles. These are interesting because they can often have chiral carbons, so it overlaps with a couple of the other groups that you've looked at. As before, I'm going to show you the reaction, I'm going to show you the mechanism, and then I'm going to ask you to have a go at a couple. So we're going to start off by having a look at the reaction of ethanal with hydrogen cyanide. So here we go. If you remember, hydrogen cyanide is a poisonous gas, so we're more likely to have this added to our reaction mixture as sulfuric acid as a source of H+, and potassium or sodium cyanide as a source of those CN- ions. And basically, we're just going to end up with our carbonyl oxygen becoming an alcohol, our nitrile group adding on to the right, and our hydrogen stays in place. We can do this with any carbonyl. What's our H here? Could be an R group, it could be a carboxylic acid with an OH group, but the essentials are this double bond here is going to break, we're going to have hydrogen added across, and we're going to have the nucleophilic addition of our cyanide group on here. So let's have a look at the mechanism of this reaction, and then I'm going to ask you to have a go at a couple. Okay, so here is our ethanal written out again, and there's our cyanide ion present. Our cyanide ion has a negative charge, and we're going to have a dipole on this carbonyl group here. So that asymmetry is going to enable my nucleophile to attack, and then I get the movement of electrons from that double bond up onto that oxygen. So I get an intermediate that's still going to have that methyl group. I'm going to have an oxygen with a negative charge. I'm going to have my hydrogen present, and I'm going to have my cyanide ion present here. That negative charge on the oxygen is going to be able to attack some of those protons, the high H pluses that are available in solution. And then I'm just going to produce my final molecule. So just take care, you can see the way I've shown my mechanism working. My product at the bottom is actually going to be slightly different to the product above. I'm going to have two different enantiomers there. So it doesn't matter too much, but it's something to just watch out for. So I'm going to ask you to show me what happens when ethanoic acid and when butanone react with hydrogen cyanide, please. What happens when ethanoic acid and when butanone react with hydrogen cyanide? Okay then, so ethanoic acid, we've got our H3C reacting with our hydrogen cyanide. So let's put the dipole onto this molecule first of all. Then I'm going to include my cyanide ion with my negative charge, set that up to make this nice and easy. Arrow from the negative charge on my cyanide to the carbon, and an arrow to show the movement of electrons from that double bond onto the oxygen. That's going to give us an intermediate. So essentially these steps are going to happen so quickly that this middle one here doesn't really exist for much time at all. It's kind of us explaining the steps of the process, so it works for us. It wouldn't really happen in any amount of time, because if you think that H plus is in solution surrounding it, so that attack's going to be instant. And I'm going to form then my hydroxy for the OH group, nitrile. So this one now has got a diol present too, so I've got two OH groups, so that's going to enable this to carry out some other reactions that we might look at in terms of forming polymers, things like that. And I've extended my carbon chain again. I now have 3 carbons in a row rather than just 2. So when you're ready, let's have a look at butanone. And here we go with butanone. I didn't specify where in your chain to put your carbonyl, so yours might be the other way around from mine, but that's all right. Our principles are still going to be the same. So we're going to have our presence of H plus and KCN. It doesn't matter if you write plus HCN, it's the same thing. And we're going to put on our dipoles. Our cyanide is then going to attack that delta positive carbon with the movement of electrons from the double bond onto the oxygen to create our intermediate. And you can see how we're going to create something a bit different. I'm running out of room. There we go. And then that negative charge on the oxygen is going to attack the H plus, and this is how we're making that hydroxynitrile. I think this board pen's a bit thick, but we're doing all right. So turning your carbonyl compounds into hydroxynitriles with the addition of HCN. I'm going to pop up some exam questions so you can try this and give me a shout if you've got any questions. Thank you. Well done.